All right, 10:03. Let's get started. Hey, everybody. Thank you so much for joining our webinar today. So the way we'll do it is we'll break this into three parts. I have Manu with me, who's one of the co-founders of Lightup and also the CEO of the company. I'll have him introduce the company and talk about the problem that we are trying to solve and why we are uniquely well-suited to solve that problem for the enterprise data stack. And then I'll jump into the product demo and break it into two parts and show you how we are purpose built to address two main pain points when doing data quality at the enterprise data scale, which is high data volume and high data cardinality. My name is Vivek, and I'm also one of the co-founders of Lightup. Welcome to the webinar. So Manu, do you want to take this away?
Yep. Hey, welcome everyone. I'm Manu, and you also have Vivek on the call. Just to quickly give you a sense of Lightup, the company, we are a 2-year-old company backed by Andreessen Horowitz, built out of a team that's bringing very significant enterprise experience. You see our pedigrees here and the kind of experience we bring to the table. Our third founder is Rajiv, who runs engineering for us. He's been in the Valley more than 2 decades now and been building distributed systems since before we had all the access to Raft and Paxos and things that we take for granted today. So between the founding team and the rest of our team, we have the ability to process data at scale, and we understand how to extract meaning out of data, right? And those are two big skill sets that are needed to make data quality successful in the new enterprise data stack, especially at the kinds of volumes that we're dealing with today and the cardinality it brings with it. We are trying to monitor thousands of tables, each with, say, hundreds of columns, and then include additional business logic that is specific to your scenario, right? So that's what the team is built for. We'll talk about those challenges. I'll talk about our unique approach and just kind of set the context for how we are thinking about this problem, why we are a uniquely good offering in the market right now, and then show you the product with the demo that Vivek is going to run. And let's keep this interactive. Please keep sending in questions. You can just write out a question. Vivek will be able to read them out, and we can just take them as they come. So we don't have to wait and make this a monologue. Okay. All right. So what is the problem we're solving? We like to think of it as data outages, right? Which is a new mode of failure when you have a data-driven application. So what I mean by that is, imagine that you're a trading application, right? And you are consuming a lot of data from external sources. That could be credit bureaus, that could be your own customer data, and so on, right? And then you're potentially pushing out data, maybe sometimes for compliance, maybe for other reasons. You're running machine learning models out of it, or you're just visualizing some of those metrics on a dashboard, right? So chances are you already have a data-driven application, no matter what you're doing at this point. For an application like that, if data breaks, basically your application breaks, right? That could mean bad decision making, that could mean bad customer experience, and that could actually mean even loss of compliance, right? And what we mean by breakage in data, or data outages as we like to call them, are things like data simply stops being available, or data is not in the right format, not in the right volume, does not follow a certain schema that you need it to be in, or the data values are just plain wrong. It's just invalid data. You're supposed to be recording dollars, you're recording cents instead, right? And you see symptoms of that all the time, where, say, $5,000 plane tickets are being sold for $50 on an end, for hours on end, right? Just because you misplaced that decimal point. So all of those are data quality issues to us, specifically the ones which your existing monitoring tools will not be able to catch, right? So you could put in all your infrastructure monitoring in place that's looking at your infrastructure, containers and VMs and whatnot, right? And then you can have your APM tools monitoring API endpoints, but there are still those issues that creep through undetected, right? And the effect is just as bad as a machine going down or a container failing, right? So what are those issues that are somewhat residing in this data plane, right, that are simply going unnoticed and are just creating havoc in your application? That's the kind of issues where Lightup really becomes powerful, right? So we'll talk more about some of those problems and show you demos. This is something that we are getting from across the board, whether it's young companies or mature enterprise organizations. It can be an annoyance to engineers. It can be frustrating where you're spending 2 out of 5 days just chasing bad data issues. But it goes beyond that, right? It's not just a frustration for your engineers and loss of productivity. It's actually business impact. This can be extremely expensive, right? So you are, let's say, a credit processing entity, right? and you start to mislabel transactions and you're monetizing that data, just imagine the impact that you're going to create. Or you're writing bad loans because you're ingesting bad data into your platform, right? So this can be extreme economic impact. It's the same kind of MO that we hear from different verticals. Doesn't really matter if you're a gaming company, a fintech company, or an enterprise technology business. Something or the other about the data keeps breaking, and engineers are frustrated, and the leader is getting embarrassed because, hey, you are having to answer to your CEO, or worse, your customer comes catching an issue and asks you, why is this dashboard not making any sense? And you're just caught as a deer in headlamps, right? So there's the same signature we hear all along. It's the same kind of experience we had as founders ourselves in our past lives, where we were building and representing data pipelines, where we would have these silent data outages just basically become those embarrassing issues that would go unnoticed for days on end until a customer would point them out, right? So how can we do better than this? Right? So why is this such a big problem today? And and I'm kind of now segueing into, why don't your old tools work anymore? Well, we have a new data stack, a new data pipeline, right? It looks like a continuous data pipeline where data is continuously being ingested from a variety of sources. That includes your end user application, but it also includes your supporting applications like a CRM tool or your product monitoring tool and so on. These applications are continuously feeding data into a central store, which is a data lake or a warehouse or a lake house, call it what you will, through some data integration tools on the way. That could be things like Segment or Kafka or Stitch Data, right? And finally, you are continuously processing this data and pushing it out into the stakeholders and decision makers and potentially your own application, right? So you kind of have that closed loop pipeline, which is continuously moving data and doing that in near real time. That's what the new stack looks like, right? And this new stack actually comes with its own new challenges and failure modes, right? So what are those new challenges? Well, kind of the big one in the room is data scale, right? We have seen 2 orders of magnitude growth just in the last 10 years, and it's exploding, right? I don't need to be even convincing you of that. So there's a lot of data volume now, and the old tools don't work with the traditional approach of importing data into a data quality tool or a data monitoring tool, right? That simply doesn't scale anymore. So that's the biggest blocker that we are hearing all around, which is a problem that we wanted to solve in the first place. That's number one. But now this high data volume actually comes with one other trait, which is high cardinality, right? So it's no longer a few spreadsheets that you're dumping into a MySQL database. You're talking about thousands of tables which are evolving continuously, right? And each one is a fat table. So you have hundreds of columns of different types. And then you potentially have views defined on top of these tables, or you have different joins being computed just in time to be served out on a dashboard and whatnot, right? So each one is giving rise to effectively a new data asset, right? So if you now start to expect monitoring, let's say every single column and every single table, I'm not even exaggerating, you're looking at millions of data assets to monitor when each one is counted on its own, right? So how do you now deal with this high cardinality? Obviously, you cannot sit and write data monitoring rules by hand in the old world as we used to do it through business rules, right? That doesn't scale anymore. You need some kind of assistance from the tool where it can just work out of the box, at least for a majority of the assets you're trying to monitor, right? And the third challenge that we're seeing, or the change which is creating this challenge, is we are now doing continuously streaming pipelines as opposed to stop and go or once a day kind of updates to your data, right? So that totally changes how you would architect a data quality tool as well. You don't have hours on end, and you cannot have manual intervention as part of your data validation pipeline, right? Data is flowing continuously, and it's going to be consumed even before someone has had a chance to look at that data, right? It would render on a dashboard, and if you didn't catch faults before it went all the way out, it's already too late. You've already paid the price, right? You can limit the damage now, but you're already starting to pay the damage. So instead, what you need is a tool that can work in the streaming setting and evaluate data as it is flowing, not after the fact, right? So, I mean, those are some of the reasons why we are seeing old tools not scale anymore, which were built with this import and inspect model, where let's say you can grab IDQ, and then it'll try to bring out data from your Redshift into IDQ. And that becomes a select star query, but that beats the purpose of having a cloud data warehouse in the first place. I mean, you went through all that effort to scale your pipeline, and now the tool just wants to come in and extract data out of that pipeline, right? That brings down the warehouse, that brings down the data quality tool, and it just slows everything down. So we're seeing, a lot of pushback against that model because it simply doesn't scale anymore, right? So just to give you a sense of, grounding the requirement from this new data pipeline, right? Um, you of course have the scaling challenge, which the incumbents are just not able to meet, right? They will let you write business rules by hand, so you can customize it all you want, but that's kind of the big value you're getting there, right? Okay, then there's a crop of new open source tools. They do a lot better at scaling. They're designed with kind of the right architectural approach, where you can leverage the scalability of the underlying data lake or data warehouse, right? So you can now push back queries into the warehouse instead of extracting data out. That is the right way to approach things, right? That's what scales. Okay, so you can get some scalability with those new open source tools and with Lightup, of course. Um, the part that's still left unaddressed with some of the new tools you're seeing in the market is the automation that you need to deal with high cardinality, right? So yes, you can scale a given data quality check. Let's say you're trying to monitor a table that has 1,000,000 rows a day, right? Now the thing is that it's not just one such table. You're talking about 1,000 such tables, right? So you're sitting and writing one rule by hand or writing one code fragment by hand that works to monitor that one entity regardless of data volume. But how do you now scale this process from a human workflow point of view to thousands of entities, right? Are you still having to kind of write rules by hand, or can we do better than that, right? And finally, if you're trying to do this in a streaming setting, that totally changes the problem. So the focus of this webinar is on two aspects, like Vivek talked about earlier. We're going to demonstrate scalability, and we're going to talk about how we can help automate a lot of this setup so that it's easy to get off the ground and easy to maintain your data quality monitoring as data shape evolves. We're not going to be talking about streaming today. That's going to be maybe the next or the next webinar or the one after. But if you're interested in how this can be applied to, say, data moving on Kafka, or how we can do this on Spark structured streaming, just reach out to us. We would be happy to set up a session and walk you through that kind of a setup as well. Okay, cool. So let's switch gears and talk about how does Lightup operate, right? So I'm going to talk about 3 or 4 different attributes of a platform, right? So the biggest one is, which is the workhorse of the system, is what we call a data quality indicator, or DQIs, right? So now imagine KPIs as you would define them in a Tableau dashboard or say a Looker dashboard, right? It's a SQL fragment or something that looks like SQL. It's a query that gets issued down to your underlying data store, right? And it computes a result for you that represents, in the case of KPI, business health. In the case of DQI, it represents data health. Okay, so that's the mindset. That's how you should be thinking about this. So the system is built with DQIs as the core workhorse. There's a whole catalog of data quality indicators available out of the box. So they will measure things that you would probably want to measure about your data pipeline as data is getting ingested and transformed and finally served out. Things like volume, delay, or completeness, right? You could do this for structured data, so clean tables in, say, Snowflake or Databricks. You could do this for unstructured data too. Let's say you're just dumping JSON or you're doing nested objects in BigQuery, right? So we can process those unstructured data entities too, and we have built-in DQIs available to do some of that, right? And then you can also write your custom DQIs, because there's always this long tail where you have a very business specific interpretation of how to measure data health. Maybe you are trying to track data volume, but you want to filter out a certain class of events, a certain set of rows by, say, a store ID or a customer identifier or a product SKU, right? So you can include that kind of filtering logic. You could potentially include some joins in defining your DQIs, right? So you get the power of the full SQL interface that is supported by the underlying data warehouse or data lake. Okay, so that's a core abstraction. That's what gets us scaling, and we'll show you this in some great detail today. Okay. And this actually changes the, kind of flips the architectural model, right? Instead of pulling raw data out, which is what doesn't scale anymore, we are now issuing DQIs as queries down into your data store. right? So that's why we're able to leverage the scalability of your lake already. Okay. Um, Now we talked about how we don't pull out data. Now what we also are able to do is correlate the results that you see on different DQIs all on the same page, right? So now you can start to cover your entire pipeline. You can write DQIs to cover the end stage where data is just getting served out to your BI dashboard. You can go further upstream and now have DQIs covering successive stages of data transformation. You can go even further upstream and look at the raw data landing stage where it's getting brought in by the integration tool, right? And now you have DQI coverage all along your data pipeline. And now if a couple of DQIs break at the same time across the stages where one is causing the other one to break, you will see that in the same pane of glass. We're going to show you some examples of this. We won't dig too much into this kind of root cause analysis feature and traversing the lineage. Again, happy to set this up in a one-on-one conversation. The third big component of the system is what we call slicing. All right. So we talked about custom SQL and the ability to write your own definitions of data quality indicators. We can also actually give you turnkey slicing where you can map your data shape onto the Lightup platform to monitor them at the right resolution, right? So an example that we see, let's take the example of a gaming company. We're talking to an enterprise gaming company right now, which is running 500 different games, right? All these games are bringing in gameplay events into the same destination table. There's good reason to do that, right? So it's not split by a game ID. But now each game has its own baseline data volume because not every game is equally popular, right? So now the question is, can we detect the games that are getting unusually low gameplays, maybe because you're dropping data on the way, so data volume is compromised, right? That's a problem statement. Well, okay, how do you now monitor all these 500 different games reporting into the same table? You need to be able to now measure the DQI representing transaction volume, but split it by every single game ID, right? So you need to be able to slice data on the game ID column, right? Now that turns out to be a fairly complicated exercise from the point of view of setting up data quality, because the traditional way here is that you will use that as a filtering constraint and then you'll set up one rule for each game separately, right? But that immediately stops scaling. You don't want to write 500 different rules, one for each game. So in Lightup, this is a one-click configuration, right? So we'll show you examples of that. So more broadly, what this means is we have the ability to model data as it's being shaped in your own tables. We've been doing this for some time now. So we have seen a lot of different ways of modeling data where it becomes challenging to just map your data quality problem down to the data shape. But this is something that we can do very well. Okay. And last but not the least, we have a very sophisticated set of techniques to detect anomalies, right? And anomaly detection is something that's kind of considered table stakes at this point. Everyone will talk about that, right? But our system is battle tested. We have been doing this again for some time on the field. We're in the third generation of our algorithms, right? But the main idea here is that we profile the past behavior of a DQI and use that as a baseline to say your DQI is now looking off from what is expected to look like. So now you're not sitting and writing thresholds by hand, because that again creates a scaling problem when you have high cardinality. How do you go and configure or calibrate the bounds that a certain volume indicator is supposed to follow, right? That itself becomes this analytics exercise, which you need to use another tool for, right? So now that becomes the bottleneck. It becomes a 2-week project to just onboard a new table just because you're going and analyzing past data and kind of debating where the bounds should be. And before you know it, those bounds become stale, and now you're always playing catch up, right? So what we have is a very rich catalog of different anomaly detection algorithms that are fitted to the problem of data quality monitoring. So that's the key here, right? You can pick up off the shelf anomaly detection. You can go grab Facebook Profit, right? Or Twitter's ESG models and say, I'm going to use this to detect anomalies. Yeah, in theory that works, but the thing is that it becomes a tuning exercise, right? And very quickly you're trying to fit this extremely powerful model to the specific problem you have at hand, and that becomes a very challenging problem in its own right, right? Instead, what we have been able to do is to exploit some empirical knowledge about what data quality indicators look like, and now this anomaly detection actually works way better, with much less effort than if you're trying to just slap on generic anomaly detection on top, right? So we'll again show you some examples of this. So I'm almost at the end of what I wanted to talk about from the point of view of our approach, but I'll just call out a few specific features that we are very proud of and have seen being instrumental in the field. I talked about slicing and our ability to map your data quality requirements onto the platform. The system is very scalable. It's actually real time. So even if you're trying to test data quality every few seconds, our system works. We have evidence. Accuracy is something that's easy to take for granted, but very hard to attain in practice. It's one of the hardest technical problems that we have solved as a team. So we don't take this lightly. And this is something that's a great um, test criteria for a POC, right? We can correlate across different parts of the pipeline. So that helps you go from downstream symptom to the root cause that is actually responsible for this fault, right? There's a bunch of features that actually make this well suited to the enterprise. We have seen this because we have come to these features because we have been working with enterprise customers, and these have come in as hard requirements, right? So there's the ability to integrate our tool into rest of your ecosystem, whether it's configuration, whether it's consuming the output from our system. Maybe you want to visualize data quality and metrics on a Power BI dashboard or on a Tableau dashboard instead of using the Lightup dashboard. You can implement all of those scenarios. I'm very proud to announce that earlier this month, we actually became a SOC 2 Type 2 certified. So big accomplishment for a team this young, but we value privacy and security because we know that we are touching your crown jewels, right? So we wanted to communicate that, and we thought the best way to do that is to actually go get certification, and that tells you that we're serious about security. And it goes one step further, right? So we don't insist that you deploy this as a SaaS offering on the Lightup cloud environment. You can actually deploy this system entirely on your cloud or your traditional infrastructure if that's preferred. Or we can do some different mixes in between where we can put data plane on your environment. So data is always in your cloud and within your security perimeter. And we are only orchestrating it from the Lightup side. So that gets you the best of SaaS and best of on-prem security. And there's one other feature that turns out to be really powerful here, which comes up as a common question. What is the overhead that the Lightup system is creating on the underlying data lake or warehouse, right? Well, the answer is not much. That's something that we have demonstrated empirically. That said, though, we go one step further. You can actually implement query governance. You can set bounds on how much load is permitted for Lightup to place on your underlying store, right? So you will not end up with runaway queries where someone accidentally built a DQI that's just running for an hour and bringing the whole house down. That cannot happen. You can control what kind of bandwidth will be given to the Lightup system and have a safeguard against these erratic behaviors. Okay. So I'm happy to take questions now. And we can always keep questions coming in on a rolling basis. And then we can segue into a demo of the platform.
So Manu, we have a few questions here. So the first one was around how long does it actually take to set up Lightup for an enterprise use case?
Why don't you take that, Vivek? I
Sure.
think you have been doing this more,
Sure.
right?
Sure. So I mean, very quickly, the way we have architected this is a bunch of DQIs that are automated, right? These are auto DQIs that I'll show you in the demo, right? So the bringing up of the system is actually very, very fast. And when you combine that with the automation that you get with the bulk configuration, as well as these rules that actually learn the bounds instead of you having to hand specify thresholds, you're able to very, very quickly set it up. And just as a benchmark, right? Most of our POCs are pretty much done within the week of us starting, because that's how quickly we're able to bring up the system, find issues that you were not even aware of, and that's what pretty much seals the deal. So when we say we are fast, we really are fast. We have optimized our deployment to be lightning fast as well. So once we get through your IT and all the approvals, our deployment works within the day, within the hour in most cases, and then we're pretty much off to the races. Configuration takes 1 to 2 days, and by the end of a week, we are up and running. And the other question that came in, Manu, was around data sources. What data sources do we support? I know you touched on it briefly, but maybe we can quickly talk about that.
Right. So we support the usual suspects. So the ones that we are seeing most commonly being used in the field are Databricks, Snowflake, Redshift, BigQuery. We do Postgres. That's also very prominent in the field. We can also do Kafka, and we can also integrate with Segment. So Kafka in particular is very interesting because that's a streaming scenario, and a subset of those checks make a lot of sense to be offloaded at the ingestion stage itself. Um, we can do this for pretty much any SQL speaking store. So if you're not listing your data source already, come talk to us. Usually we'll take 3 to 4 weeks to add support if there's sufficient interest for any SQL speaking source or something that looks like SQL. So if you want to do this on Cassandra, let's say, right, we can talk to CQL. So depending on what your source is, we can tell you how long it'll take to add support for that source.
So one more question before we move on to the next section. So this is around, how did you get the idea of this new data pipeline? Was it like an internal discussion, or was it learned at a conference, or something you heard from the customers?
So the data pipeline here,
I guess
idea
the
of
new
the
data
data,
stack, new data
new.
stack, and it needing a new solution.
I mean, this is something that we are seeing all around. I think what where this is probably anchored is this transition we're seeing actually right now, going from what used to be ETL pipelines to a more ELT style of workloads. Um, before Lightup, I built a company called Uhana, and we were building an ETL pipeline for telcos, and we were processing 3 million events per second, and that was happening at sub-second latency, right? So that gave me a lot of experience in what a data pipeline looks like. It was built out of Kafka, bringing in data in real time, feeding it into a Spark pipeline and a Heron engine that would do complex event processing in a streaming sense, and then pushing that out into a time series database like InfluxDB. So we've been kind of studying what pipelines look like, what are people now trying to do, and they're trying to go to sub-minute response time for data getting ingested all the way to rendering it on the dashboard or feeding it into a machine learning model. But it's just mainly seeing what's happening in the field. And hopefully that answers the question, but happy to answer more specifically if you have more angles to pursue.
All right, so we're at 10:30, so I'll get started with the product demo side of things. But quickly, Manu, there are some questions in the chat as well as some open questions that you can even type out answers to as you see fit. Yeah.
All right.
Okay, so cool. So thank you for that introduction. So what I'll do is I'll give you the two specific problems that we're trying to solve. I'll show you how we do it using our product, right? So how do you deal with high data volume? So how is your system scalable? And then in the second part, I'll talk about how do you deal with a high data cardinality, which is where automation comes in. So let me quickly share my screen. So you able to see my screen just fine? Yeah, all good. Okay, so this is what the Lightup platform looks like. So two main sections. Dashboard is where all your metrics live. This is all the metrics that we're tracking, or data quality indicators, right? They're measuring different aspects of health. Incidents is where, as we find these data quality issues, you'll find them under incidents. You can filter based on the schema, table, or the column. You can filter based on time and get to the kind of issues that you want to address at that day. And then in order to get started, you get started simply by connecting a data source, putting in your data source credentials, and then when you hit test connection, Lightup is able to establish a connection to the data source and will show you all the tables that we have access to. Once you see that, you're able to save this, and now all of these data assets are available for you to start looking at and measuring data quality on. If you wanted to turn on data quality for, say, a specific combination of a table or a column, for the metrics that you get out of the box, the auto DQIs, they are pretty much as simple as turning on profiling and then specifying which metrics you want to track. So for example, if I wanted to look at say a New York Times US COVID table, right? I'll click enable. Lightup will automatically find a timestamp column that the table is indexed on, and will propose something in terms of how the metrics should be calculated. Right now, we're proposing we can calculate it hourly. You could change it to every few minutes, every day, or whatever the frequency that you want is. And then you can click profile now. And that turns on profiling. You turn on data delay, you turn on data volume, and that's all you need to do. No SQL to write. Lightup has these queries inbuilt. These are all scalable in-place queries that you now start running. So now once you've set this up, Let me show you on the dashboard the kind of DQIs that you're able to set up and the kinds of issues that you can find. So here you can see we're tracking a bunch of data sources: BigQuery, Databricks, Postgres, Redshift, and Snowflake. Let me focus on the Postgres demo data source. So at the data source level, you can quickly see how many tables are in the data source, how many of them do you have data quality coverage on, and then you'll also start seeing cases where a new table gets added or a table gets inadvertently deleted. Now, if you were to look at a table, what we track at the table level as the data quality indicator is the schema of the table. So this is the list and data type of each column. We track data freshness or data delay, which is the time since the last event timestamp. And then you'll find issues like this, right? So for example, if this pipeline gets updated every few minutes, you'll see that the data delay is of the order of a few minutes. Now, if all of a sudden this data delay spikes, this is when Lightup will indicate that there is a data quality issue. Either the pipeline failed or the integration is an issue or the third-party API is not giving you fresh data. And then that the data delay looks high. So let's quickly take a look at this incident. And when you look at the incident, basically what it tells you is what the data delay used to look like and what part was marked as an incident. And the way Lightup is doing this is you're not setting up any thresholds. Lightup is learning the normal behavior of data delay based on this metric's own past. So in this case, this data quality indicator, which is data delay, is typically of the order of, say, 3,000 seconds, which is close to, say, 50 minutes or so. And now all of a sudden, some updates were missed, and you'll see a spike, and that's what Lightup catches and alerts you on. So in addition to data delay, we're also tracking data volume, which is the row count per unit time. And so again, this is a snapshot query, which is counting the row count. Say if it is an hourly query, you're counting the row count every hour. So every hour the system will wake up and ask for the row count in the last hour. And that's what makes the system scale really well, because you're leveraging the warehouse. Let me give you an example. So here is a case where data volume is being tracked for a table with millions of rows. So if you look at the daily row count, it's of the order of 5 to 6 million, right? And we found an issue where it dropped down all the way to 1.5 million. Now, just to show you why this scales, right? So think of doing this in an incumbent system. You would first do a select star on all of these tables and run all of these data quality checks on the data that you then get out of it, right? And what we've seen at a bunch of customers is that that's something that puts a big load on the warehouse, not a scalable way of doing it across many such tables. And it's a significant compute burden as well, because now you're scaling up another system that is able to deal with this data volume. And what Lightup does instead is run in-place queries. So what I've done is I've pulled up the logs just to show you the kinds of queries that we are issuing. So here is the query that we're issuing for this high volume table, for example. You'll notice two things. One, that we are only calculating aggregate, so no select start. We do not pull out data. So this all the aggregation is being pushed down to the warehouse. And two, that it is time bound on the timestamp column which the table is indexed on. So again, for this query, we're only asking for data for the last day when the system wakes up every day, and no more. So you're only scanning a very small amount of data. Never do full data scans, full table scans, and these are very, very efficient queries. So think of like if you run these checks at high data volume in incumbent systems, you could see them taking hours if they succeed at all. We've run into cases where some of those queries were just banned by the DBAs. But if you did succeed, then it'll take a few hours. And in this case, it's a few second long process, a few seconds or a millisecond to run this query, and then a second or so to run the check. And that's how fast the system works. And that's really what lets it scale. So now let me quickly show you some of the other kinds of issues that we are able to catch with DQIs. So we can catch things like changes in schema. So a column gets inadvertently removed, or the data type of a column changes. In this case, a column password was just removed. Maybe this was not a change that you intended to do. Maybe this is a bug. So Lightup will catch it and highlight it for you. There could be now, once you know that the data is in the right format in the table and you have the right data volume, the next question that you have is, okay, what does the content of these columns look like? And again, these are things that we track out of the box for you. So there are things like null checks. So we calculate the percentage of values that are null in a column, again, per unit time. And so if you look at this column, typically you have some baseline of missing value percentage. So 1 to 2% of values are null, but all of a sudden it spiked. Again, Lightup learned the baseline behavior and was able to catch such an issue. And we also track for a numerical column the percentiles. So these percentiles are a summarization of the overall data distribution. And so if there are cases where, for example, there is a drift in a column behavior, again, maybe it's a bug. So for example, here we're tracking the distribution for a column called value. This is getting the distance in miles, and the scenario that is modeled is that the data changed from miles to kilometers because of a bug in the transformation code. And all of a sudden, you see this 1.6x shift in the data. Lightup learned what the distribution looked like for this column and was able to catch this issue. Now, if your column is categorical, then the way the distribution works is you're tracking the relative frequency of each of the categories. So the example here is that of a gaming company. And in this table, you see data for 5 different games: blackjack, slots, baccarat, poker, and rummy. Typically, the relative frequencies are roughly the same, but then Lightup highlighted one of the days as incidents. And if you look at it and compare it to the last day, you can quickly see why. Rummy started recording way fewer incidents than it used to. And again, Lightup learned this based on the signals passed, and maybe this was a new software version that was pushed, and all of a sudden, Rummy-related events started getting dropped. So this is where you'll catch it with the exact identification that Rummy actually is dropping incident. In addition to the relative distribution, we're also tracking the list of categories. So suppose you get data from these 5 games, and all of a sudden, one of the games stops feeding data. You'll catch it here. So we've seen this scenario happen many times for customers. Say you're getting data for many different states. All of a sudden, you get a new state because the same state is being mentioned as 2 different names, or a state drops altogether. You'll see all of those issues and catch them in the list of categories. So those are the data quality indicators that you get out of the box that you can enable with a single click. And just to drive this point home, think about all these different data sources. The behavior that we are trying to code is very similar, right? You have these time-bound in-place queries. So here, for example, we're looking at a Snowflake data source. And this is the public data set for Johns Hopkins University for COVID data. Data comes in once a day, and that's why data relay looks like this. Every time data is updated, you see that the data relay drops. And then you have this data volume that is weekly seasonal. But if you look at the query that we are issuing, you'll notice the same 2 things. So I'm on the Snowflake query console. And just to give you an idea of how this query gets translated, again, you will notice that we are doing an aggregate query, not pulling out raw data. And again, it's time bound on the timestamp column. So which again makes this query very, very efficient. You don't scan a lot of data.
Vivek, a question came in. So does Lightup tell you about the change in data model too?
So data model as in the schema?
Yeah.
Yes, so that's exactly the use case that I was trying to show. So here is an example where the schema changed. So here's an example where the schema changed. And this table has 4 columns, and one of the days, a column called password was inadvertently dropped. Now, if the data type of this column changed, for example, Lightup password went from a string column to a numerical column, again, you will find that issue. So any kind of changes to the list of the column or the data type of a column will be caught and alerted on. Lightup will generate an event for them.
And one other question is about what kind of access is needed to the data store to set up this integration?
So this is all read-only access. We don't write to your data store. We don't modify anything. And very, very basic read access is all you need to get started. We need to be able to read the schema. We need to be able to issue these SQL queries to get these aggregate results. So one more thing that I wanted to touch on was this concept of custom metrics. So right now, what I showed you is what you get out of the box as data quality indicators that you can mass apply on all the tables. You can also create your own custom queries to actually look at a business specific data quality indicator. So these are things that maybe where you want to slice and dice the data, look at it at a fine enough granularity. For example, here, the example is that of a restaurant ordering app, and you're looking at the order value coming in by OS version. You know that your app behaves differently across different OS versions, and you just want to track that behavior. So what you've done is you've used the features called slicing that Manu talked about, and you're able to then have Lightup treat each OS version as a separate metric. You can write your own free-form custom SQL that joins across different tables or does different kinds of filtering, and you can get the query that you want, that you would envision on a business dashboard, for example. And now Lightup learns the baseline behavior for each of these separately. It can highlight issues where, say, all OS versions are affected. It can also highlight issue where only one OS version was affected. So if you're looking at the overall metric, you wouldn't even find this kind of issue. But now between full custom SQL that you can use to specify business logic, and out of the box DQIs that is an ever expanding menu where we keep automating things, you are able to get full data quality coverage on the warehouse. So I'll take maybe a minute or two there, Manu, if there are more questions.
So there's one question being asked about how do you scale this configuration if you have high cardinality and thousands of tables?
Great. So that's a perfect segue into the second part of the presentation. So maybe if there are no more questions, I can directly jump into that. But the idea is automation. You do bulk configuration on both the metric itself as well as the anomaly detection. So anomaly detection basically lets you not have to set up thresholds, and you're able to then the workflow works. So what we've heard from a lot of customers is that I have thousands of tables, hundreds of columns per table, and how do I set up those metrics? And two, my workflow currently involves setting up thresholds that are tweaked over time, say weeks of data, weeks of work before you can call a set of data quality indicators ready to report on. And that's because you set up some thresholds, you see how often they alert, then you basically adjust them over time till you get to a point that you like. But Lightup takes away that need, because what you're learning is the temporal behavior of that data quality indicator. We learn that automatically, and so you don't have to set those bounds at all. So when you combine those two, it's actually a very small amount of work, which is what I'll show you next. Any other questions?
That's all we have for now.
Okay, cool. So let me quickly talk about cardinality, right? So cardinality is the other big issue that we've seen where for customers that have been using some of these incumbent solutions. And even as Manu mentioned, right, some of these new open source alternatives that are coming out, like Great Expectations or DQ, they let you create these metrics, right? But again, each of these is a check that you have to set up, and both the metric itself, which could be done through code, but then the second part is how do you know when a metric is behaving abnormally, right? And those are thresholds that you have to set. So as an example, you might have to say, tell me when a column value is value is outside this range. How do you come up with that range? You profile it, maybe a few days of data outside of the tool, you come up with those bounds, right? That's not an approach that would scale. So how do we address that problem? Bulk config is the first part. So let me show you bulk config, right? Initially, when I showed you how to set up this system, I showed you how to do it for one table. But the same operation is actually available for a set of tables. You could just go click all the tables, click profile, and at this point, you are ready to enable out of the box data quality indicators on all the table. You could filter by a schema name, you could filter by a set of tables, you could filter by a product name, and quickly get to the list of tables that you want to start monitoring. Once you've done that, all of these operations are bulk, and within a few clicks, you will now have full coverage for the table level DQIs. The second thing is
Vivek, while you're on this topic, there's a question on are we pulling metrics on metadata as well that can help with data discovery? So I think what you're showing here is the list of tables, right? So that's an example of data that's getting pulled out automatically. So you're not sitting here and listing out all the schemas and all the tables and columns, right? So that's being discovered. And then maybe you can also comment on data types.
Yes, so essentially, so let me quickly show you here that an example, right? So next thing is, okay, now I have several columns in a table. How do I set up those DQIs? So I could take a look at some of the columns, right? And again, for each of these columns, we will discover the data type. We will discover, when we do these schema checks, we are discovering the list and data type of each of these columns just based on metadata itself, right? And again, for columns, suppose I had to, this table, for example, is 200 columns. I wanted to set up null checks on all of them. I would just go ahead and select all the columns and then select enable null checks, right? That's all the work that is needed. I wanted to track distribution for all of these columns, again, the same amount of work. So with these many clicks, I am all set to actually start tracking these metrics. And this is for the out-of-the-box data quality indicators. You can quickly see, right, how easy it is to just get started and start getting these metrics on the dashboard. And then if you have a custom metric, again, there's the same question, right? Suppose I have, and we have had these examples. There have been 10,000 entities that the customer wants to monitor as slices. Think of, suppose you are a store chain, right? And you want to monitor each store because they can break physically in a different way. You're a restaurant business. You want to track each restaurant because each restaurant may fail to upload data. That's not something that will show up at the aggregate level, but that's something that you will catch if you're tracking at a per restaurant level. So what we give you is the power of full custom SQL. So here, if you see, there is, you can write out SQL, and there is a single group by query, right? That is hitting the DB. Say you want to break it down by OS version. You have a slicing column called OS. You specify that, and that's all the work you have to do to set up slices. Now, if there were 10,000 OS versions, Lightup will automatically detect them as different views of the same table, if you will, learn the baseline for each OS version separately, and then start alerting you if there are incidents on a particular OS version. So but the query that is hitting the warehouse is again a single group by query. Rest, everything happens in the software. So it's still very, very efficient. You are still able to get the scale because, hey, I wanted to set it up for 10,000 restaurants. I just select a column called restaurant, and that's all the work you have to do. Beyond that, it's Lightup that is doing all the heavy lifting, creating all of these as sub metrics, which are based off of the same query, and then learning the baseline behavior. And now, once you have the full coverage, right, now you can go as wide as you want, get all the metrics that you want, because these are all very, very efficient queries, right? You get this, get the coverage you want with very, very little load on your warehouse, right? And now it's about setting up bounds on these queries, which is something that we do uniquely well. And that's the second part that I want to show you, what kind of detection, how our detection algorithms work in practice. Because to be able to detect things at this cardinality, right? If you have millions of data assets, and if you have a false positive rate even of 1%, think of the number of alerts that you'll get, right? So you really have to get a really good anomaly detection system in place that is purpose built for these kinds of signals. That's what I'll show you next. I didn't talk a lot about the incidents tab, but basically here you can filter it based on time, based on schema, based on a data asset, and look at all the incidents that happen. I'll look at one particular one just to use as an example. No questions so far, right, Manu? Keep going. Yeah, okay. So this is what an incident detail looks like. So anytime we detect an incident, if you have configured an alerting channel, you get an alert on that alerting channel, as well as it gets added to the incidents table. Clicking on the incident will land you in an incident. You'll get an idea about what the data asset is, what source, what table, and what it is. And then you'll know why it was flagged, because there was a sharp change. You have a way to pass feedback. So if you don't like an incident, you think it's a false positive, you can pass feedback to the system by rejecting the incident. So accepting the incident means that you like what you see, and both of these are used by the system as labels. So rejecting an incident will both remove it from view, so it'll go into a list of rejected incidents, but it'll also use as feedback for the system, in which case the system knows that the kinds of incidents that were shown were not found to be useful, and the model needs to be updated. And so now let's look at this incident. And the third part of this is correlated incidents, not something that I'll go into a lot of details, but this is a feature that comes in very handy when you're trying to root cause an incident, because you're able to see all the other incidents that were happening around the same time. So if you wanted to understand the downstream effect of, say, an incident in the upstream table, you can look at all the effect here, put together an incident report. Or if you are looking at a table downstream and want to know what happened upstream that caused this issue, you can also traverse the same set of incidents to be able to get that cross lineage root cause analysis going. And you can add it to the report, and that becomes your incident report. But that's a session of its own. I will focus on the anomaly detection. So you see that there was a drop, but maybe not. This is not enough to make a conclusion, right? So let me zoom out. And now you can see that this is a signal. Let me zoom out a bit further, actually. So you'll see a lot more about this signal. So you see that what the signal is it's daily seasonal. There is a somewhat of a trend, right? So if you compare the level here, where the metric was slowly decaying, and then it started picking up, then it started going down, right? And so it has some trend, it has seasonality, it has variation, right? And this is what most real business signals look like. You send out a marketing email, more people show up. You send out there is COVID, you see a gradual decay, right, in certain metrics. And those are not the data quality issues that you're interested in. So if I gave you this on a chart and I asked you, mark for me the data quality incident that you would like to catch, most likely this is what you will mark. And that's precisely what we got, right? We didn't catch any incidents when, for example, the level went down to this level. So if you compare this level to this level, it looks very different. It's almost 30% change. But that's not what we are marking. We have algorithms that understand that data quality issues actually look like a sharp change, and it's a sharp deviation. So it's almost the signal is changing too sharply at that point in time, but it's comparing the signal to its own local past and to a learned behavior. But as a result, the resulting rule that you get is very, very robust. You are able to catch only the incidents that you want. And this is field tested. This is what we've seen time and again. But just as a proof point, I've also created a basic rule that uses one of the textbook techniques. So textbook techniques, basically what they suffer from is they work very well when the data matches what you trained it on, right? So here, for example, if you trained it, this is a rule that I trained using mean plus minus 3 sigma kind of an expectation. And let me bring those expectations into view. So now what you'll see is it was trained for when data looked like this. Now, as soon as there is some trend and data starts moving, you'll see it starts flirting with these bounds. And if it trends down, again, it will start flirting with the bounds. And each of these gray is an incident that this detects. And this is something that will inevitably happen in practice if this is the kind of detection you use. Doesn't matter if you bring Facebook Profit into picture or a different tool, because it's trying to extract some behavior of bounds around the signal from some past that it has seen. But that's not a technique that works very well in practice. They decay very, very fast. So here, as soon as it started flirting with this lower boundary, you can see the number of incidents that were generated. This is what inevitably ends up happening to most of these kinds of detections. And that's why when you talk about anomaly detection, people have this notion that how well would it scale? But we have battle tested Lightup's algorithms, and this is the performance that you get. And when you get a performance like this, that's when you can truly combine it with the automation that you're getting from bulk configuration to be able to run this kind of a detection on all the DQIs, right? And then when the incidents that you get are actually meaningful, and you can confidently then go about turning them on live and monitoring in production.
Vivek, there's a question on do we have any data on the accuracy of our system?
So I can give you what we've seen in practice. So the last benchmark that we did was there was a rule similar to this at a gaming company, and they were getting out of the 70 alerts that they were generating in a day, about 10 of them were useful. When Lightup went into production head to head, we actually caught for the same day exactly 11 incidents. 10 of them were useful. The 11th one was also borderline useful, but we used that as feedback. But that's the kind of accuracy that you're able to get. We've seen in production the things that were like almost 80-90% false positive go down all the way to like less than 5% false positives. And this is
I'll
something that is
just
best. Sorry, go ahead.
yes. And I'll add to that just based on what I was talking about earlier, right? So what you're seeing here is a way to detect the anomaly as a sharp change as opposed to a deviation out of bound, right? Why does sharp change make sense? Because that's what data quality issues typically look like. I can't say that about a business metric at large, right? That may not be the kind of anomaly that most metrics present with or the ones that you are interested in. But for data quality, what we have seen is that there are specific patterns that show up very commonly for which you can design very well suited algorithms, right? Sharp change is one such example. And then they outperform more stock or textbook techniques like doing Z-score or doing MAD like implementation, which is the one that Vivek is showing you here.
Okay, and the other thing that I was trying to say is this is something that we are very confident in showing in a trial, right? So as I said, things are very easy to get set up, and we can quickly show you how this works at scale, and that's what has pretty much been a winner for us, right? When we go into a customer environment, we find issues that they were not aware of, and at the same time at an accuracy that they're very amazed by. Yep. So that's all I wanted to show as a way to talk about how we let you address real enterprise use cases, not create a few toy examples, but actually make the system work at an enterprise scale. I talked about how you deal with how high volume data with in place time bound queries, and then how do you combine bulk configuration with accurate anomaly detection to actually do this at scale. Happy to answer any questions now or offline. If you guys want to try out the system, reach out to us. And I hope you found this useful.
And I'll maybe just show one slide in closing. So I'll take the screen again. So going from here, I encourage you to go to our website and scroll over to docs, or just go to docs.lightup.ai. We have instructions published on how we deploy at enterprise scale. We also have instructions how you can get started, and it'll give you a sense of what the different deployment options are, and you can pick the one that suits your privacy requirements, and you will see that each one takes less than an hour to get set up, right? So that's literally how simple it is to get started. You can directly go to signup.lightup.ai, or just find a button on the web page and request a trial. We would be happy to set you up. And we are hiring. So if you know people who are interested in positions with Lightup, please do refer them to us, and they can just go to our website and find how to get in touch with us. You can always write to us at info@lightup, or you have our email IDs here. Feel free to drop us a note for whatever you want to talk about. Would be happy to pick up a conversation after this webinar.
All right. Thank you, guys. Thank you for giving us this hour, and I hope you found this useful. Looking forward to hearing back from some of you. Bye.
Bye.